This is Vahid from VRF Education channel, and it is the 11th session of object-oriented programming in Python. Today, I'm going to talk about inheritance, one of the most important concepts inside object-oriented paradigm. Many developers believe that without inheritance, object-oriented paradigm wouldn't be where it is right now. Inheritance in OOP is somehow like its usage in real world, and as I said before, OOP is a way that we can model real-life object and its relation in our applications. For example, in a real world, a person as a child inherits some characteristics and behaviors from his or her parents. And also, in addition to that, imagine a house or a home. In that home, the father owns a car. So the other children that inherit from that specific father can also use that car. So they have something in share to each other. And this concept can be easily achieved by inheritance in object-oriented paradigm. Let's talk about this concept a little bit in detail. As the definition implies, inheritance is a mechanism that allows us to create a hierarchy of classes that share a set of properties and methods by deriving a class from another class. And this is the notation that's used in UML diagram. Here, subclass inherits from superclass. So this is the base class, and I'm going to cover this concept very soon. And this is the child class. So another way we call it parent class, and this is the child class. The child inherits the public and protected members of its parent class. Okay, and we have different type of inheritance in Python, and we will get to this very soon. Here we have two type of employee in our application: full-time employee and part-time. And we want to model these two entities. And we know that these two type has a set of common properties and also methods or behaviors. Name and a starting date of their works at the company or something that is common between these two type of employee, and also set name and set started again is some common behavior between these two type of employee. So without inheritance, we need to repeat this set of properties and methods in these two classes. But with inheritance, we can move the common behavior to another class named employee. This is a very general concept in our application. We have some employees, and then we can make it abstract. I'm going to talk about abstract class in future. So we cannot create instances of abstract classes, and they just here to be a directive for us, something like that, and we will get into it in future sessions. And then we create two other classes to model our real entities, full-time and part-time employee, and they inherit from employee class. So here they can access to these common objects, and each one has its own set of data. Okay, and here we can add a specific items to each classes. For example, here hours worked is a specific for part-time employee, and also the behavior set hour works is somehow a specific for this type of employee, and also for full-time we have another options. Okay, so this is the way that we can model our objects. We can move shared properties, fields, and also behaviors to another class and inherit from that. Let's see what is the advantage of inheritance. Inheritance provides a lot of advantages. The first one, as I said, it represents real-world relationship well. So you can model your real-world entities into your application based on the relationships. And it's very important when you want to create some application that is somehow related to one real object in a real world. And also it provides the reusability of code. It's very important. You don't need to repeat some common properties and also behaviors or methods in classes. And this is going to help us when we want to make a change inside those common stuffs. For example, we don't need to change a method behavior in 10 different classes. We just need to change it inside the parent class. And also it's transitive in nature. For example, if class A derived from class B derived from class A, then if class C derived from class B, then C also derived from class A. It has all the capabilities that be inherited from class A. And again, it's offer a simple, understandable modular structure. It's very good to learn it and make use of it. And also we have less development because we just cut the amount of code we need to write, and also the maintenance of the code and also the expenses will be reduced. In relationship structure, we only have two different type of classes, parent class and child class. Parent class is the class that being inherit from. For example, in this sample, employee is our parent class, or it's called superclass or base class in other programming languages. You are free to say anything that you want to it, but keep in mind that the role is to being inherited from. And the class that inherits from another class called child class or derived class or subclasses. For example, in this scenario, part-time employee and full-time employee are the child of employee class. This is two types of different classes in this structure. We have 5 different types of inheritance in Python: single, multiple, multi-level, hierarchical, and hybrid. Hybrid is a combination of these 4 types, in fact, and let's see their definition in some shapes. Single inheritance, we have only one parent, and a child will inherit from that specific parent. And in multiple inheritance, a child will inherit from 2 different parents. Okay, imagine you have the dad and mom, and you inherit from both of them. So here we have multiple inheritance. In some other programming languages, such as C++, we have multiple inheritance, but in others, such as C# or Java, we don't have support for multiple inheritance. Another type is multi-level inheritance. It says that we have a parent here, and it's the main base parent, and another class derived from this class. This is our intermediary class, and also you can make use of this class sometimes based on your logic in your application. And here we have a child that inherits from parent 1. So child will implicitly inherit from parent 2. This is how we call the inheritance is transitive. Child inherits from the parent of its direct parent. Okay. And here we have hierarchical inheritance. We have some child that inherit from a parent. Oops, it should be parent 1. I forgot to correct it. And if we try to combine this kind of inheritance together, we get to hybrid inheritance. Now let's go to VS Code and start from the simplest one, and then in another session I'm going to continue on the concept of inheritance. Okay, let's see inheritance in practice. As I mentioned, inheritance is one of the most powerful feature of object-oriented programming that can help us to reduce the amount of code and also better management of entities inside our application. In this session, I'm gonna model a football team inside my application. So I want to create a class for different type of player inside a football team. As you might know, there are a couple of different player type inside a football team. For example, goalkeeper, defender, midfielder, forward, and some other types that I don't want to talk about. Now I want to create a class for each type. First of all, I'm just gonna create those classes without adding anything to them. Goalkeeper, defender, class midfielder, I think it's something like this, and class forwards. So as we mentioned in previous sessions, every class has some fields and some methods for their characteristics and their behavior. All of players inside a football team have name, age, number, and as the methods, they can walk, they can run in the field, and some actions are related to a specific type of players. For example, a goalkeeper can dive, or a forward can dribble. So these are specific to a special type of players, not all of them. Let's add things from scratch to all of them. So I'm gonna create a constructor for goalkeeper class, and it receives a name, age, and a number for goalkeeper. And again, I'm gonna add them to some field inside of this class. Self.name equal to name, self.age equal to age and self.number equal to number. I'm gonna copy this one and paste it to the other fields. Now these are some public fields and we're not gonna get into private field and properties in this session because I just want to demonstrate the inheritance concept. Now some players might have some player type might have other characteristics. For example, I want to add dribble coefficient, dribble underline COEF, dribble coefficient to forward self.dribble underline COEF equal to COEF. So this field dribble, this field is specific to forward and the other one doesn't have this field because they don't need it. And for example, for defender I want to add something like jump coefficient equal to jump coefficient. And for the other one, for example, for goalkeeper, should we add anything else? Here I want to add imaginary field can play with foot. If this player able to play with his foot safely or not. Can play with foot. So this is it. And midfielder doesn't have any extra parameter rather than those that is coming with the other type of players. Now let's add some common behavior or activity that all players can do. For example, I want to create a method walk, and if I call it, I want to print something on a screen. Player walk. And also I want to add another method run player can player run. And because this is common between all of those classes or those player, I want to add them to these classes. And this one and this one. So now if I create an instance from each class, for example, C1 is a goalkeeper, or G1, not C1, goalkeeper. The name is G1, values 1, 1, and true. So if I open the IntelliSense for G1, you can see all of those fields and also run and walk method. And let's create a forward, F1 equal to forward, named F1, number 2, age 2, number 2, and dribble coefficient is 1. This is something between 0 and 1. And if I open the IntelliSense for this one, you can see I can call walk, run, and also field number, name, and age, and dribble coefficient are accessible through this object. This is obvious, and we already know this. So what happens if I want to change the body of this method or this behavior? This is common between all of those classes. I should change it in all of these classes. Okay. Now, before I get into this, let's add a couple of individual activity to each class. For example, a goalkeeper can dive. So I want to create a method named dive, and now I want to print goalkeeper, GC, goalkeeper, dive. And for defender, I want to add something, for example, block. It blocks the opponent, self, print, defender, block. And again, for midfielder, I don't want to add any extra things. And for forward, I want to add a method called dribble. Print forward dribble. So these methods are specific to each class separately. Forward can dribble. Midfielder has nothing in addition to these common behaviors. A defender can block, and also a goalkeeper can dive. So here, if I just use G1 dot, we can call dive, but there's no dribble method appear here. And for F1, we have dribble method, but dive is not presented here because it's defined in the G1 in the goalkeeper class. Now let's focus on common things. You can see that all of the player can walk and run, and all of them have a couple of fields in common: name, age, and number. And if I want to change the body of walk or run, I should change it in 4 different classes. And for a real application with hundreds of classes, without using inheritance, it's turned into a nightmare after a couple of months when the application grows dramatically. So as I mentioned, inheritance is one of the powerful and fantastic feature of object-oriented programming that can help us to reduce the amount of code. As you can see, there are a lot of code written here to implement or add this functionality and these things in common to each class. And we have a lot of line of codes here, and we can reduce it, and also we can maintain it better using inheritance. So what is inheritance? In inheritance, we should find something common between different classes that are logically related to each other. All of these classes are used to model a player. So forward, midfielder, defender, and goalkeeper, they are all a player. So I can create a base class or a parent class named player, and then inherit from that in the other classes, in the children, for example, goalkeeper and the other ones. So what does it mean? Let's create a player class. This is a base class, okay? And I'm gonna add, let's copy this from here to reduce the amount of coding also. So in the base class, I'm gonna use the common fields. So I should get rid of this can play with foot. This is specific to goalkeeper, not the other ones. And this is also some common activity between all of those players. So here I can get rid of these extra line of code because I'm gonna add the use them from the base class, and also this one here and here. Look, we are going to maintain the specific or individual methods and also attributes inside the children class. We're not gonna omit them. And also in midfield, I'm gonna pass and forward. Okay, you can see our final code is much more cleaner. So how can I say that you are a player? You should inherit from the player class. To do this, after the class name, we open parentheses and name the class that we want to inherit from. So I'm going to inherit from player. Now, if I'm come here and say G1 dot, you can see I can call run and walk over the goalkeeper instance because it's a player class now. It inherits from player, so it can access to all the capabilities or all the options inside the player class. Okay, but in forward it's not available now because I'm not inherit from player right now. So if I just inherit from player for forward, it's also a player. Now if I open the IntelliSense, you can see, yeah, run and walk also available to call from the F1 instance. I can run it. Let's run and see the output. Okay, player run. Now I'm gonna inherit from player for defender and also midfielder player. So I'm gonna print f1.name. because I pass a name to it and it inherits from the player class, and player class also has a field called name. Let's see what happens. It says that forward object has no attribute name. And that's right, because I just received the parameter here, but I didn't assign it to the parent class or do anything with that. Whenever we inherit from a class that it has a constructor and we want to pass some parameter to them, we should call it explicitly. So here I should say player dot dunder init and pass the parameter self, name, age, and number. And these are common fields that I received from the outside, and I pass it to my parent constructor. Let's see. Here I have f1 because when I called the init method called here, and then after that the name is initialized inside the parent class. Now it's inside the parent class and I can access it because it's mine now, because I inherit from the player class also. Okay, and we should add this call to the first line of each constructor of the other classes. And here we can use a super method. Super method is something like that we add or we mention the parent class. We can use a super call instead of naming the parent directly. So if I saved it, in this way I should delete the self parameter because it's sent to the parent class automatically when we call the super function here. And if I run the application one more time, you can see the same result gonna show on the output. There's a difference between adding the direct base class or calling the super function, and I will cover it in more detail when I talked about multiple inheritance in future. Now let's add this line to these constructors, and also this one and this one. Okay, right now all of them, all of these classes are a player, and we can access these fields inside the base class, and also we can use these common methods in these fields in these instances of these classes. Okay, so and let's run these two. For example, I want to say is instance on G1 and player and duplicated G1 on goalkeeper. So it says that G1 is a goalkeeper, and meantime G1 is also a player. But if I change it to defender, although they defender and goalkeeper both inherit from a player, but G1 is not a defender. Do not forget it. First one is false and the other one is true. So when we inherit from a class, our instance of the children is also an instance of the base class, and it's very useful, and we will talk about it in future. And it's play a vital role when we want to use polymorphism in our application. I hope you enjoyed the content for the inheritance in Python, and I will complete it in future using other concepts. And the main concept in this session is how we can inherit from another class, and how we should move common things inside the children class to a parent class. Okay. Okay, I would be glad to hear your comments. Please let me know about the quality of this video series, and till the next session, goodbye.